Welcome back, everyone. Welcome back. Okay, so we are into our third session of the day for What's New with Amazon Aurora. My name is Aaron Hunter. I am a senior technical trainer with AWS training certification. And with me, we have right over here.
Brian Terry. I'm a senior developer advocate on the CloudFormation team. And again, if this is your first time joining us, we're excited that you're here. And we also have an opportunity for you to win some AWS credits. So stay
Ooh,
tuned for
win. Oh,
that.
is that like free money?
It's free money. And then we're going to talk about right now how you can maximize that free money. So
Cost optimization with Amazon Aurora. All right. And
absolutely.
who's joining us? That's Venkat.
Yeah, special guest, Venkat.
Venkat, where are you? Venkat, come on. Come on to the stage, Venkat.
I'm here. I'm here. I'm here.
Looks like you had to drop and come back.
Yeah, technical challenges, I guess, always happens, right? And I'm glad that I'm able to make it now. And so, it's a tough act to follow, actually, Aaron. The two guys in front of me, they're amazing, right?
Justin and Jerry did a great job for sure.
Yeah. And I'm kind of stuck with a very boring topic which nobody's interested in, like cost optimization.
Cost optimization.
Who wants to know about cost optimization?
Yeah. Everyone.
Yeah, absolutely. Right, so
it's $500.
So let me ask you this question, right? If cost is a lot of times we have talked to our customers, and we find the cost is the final hurdle for them. And I've been in the database industry for 25 years, and I want to introduce myself, Aaron, as you want me to go with Rajan. I'm a database solutions architect with AWS, and as I mentioned, I had 25 years of experience in doing databases, right? Database technologies, and currently I'm a database solution architect helping our customers with different database services we offer. And today we're going to talk about, we have a great exciting topic around cost optimization, and agenda for today's meeting is we have, first of all, going to talk about different modules of Aurora and cost optimization on that level. Then monitoring metrics, right? We want to see how can we use metrics to monitor our cost, and tracking our cost is pretty cool. And finally, I want to kind of also have a designing our sustainability model, right? Based on sustainability. So let's jump right in and talk about cost optimization in Aurora. Right now, Aurora has the pricing for Aurora is based on 4 different categories, right? It's based on the cluster, right? The instances you provision, right? And it's based on the storage you use and the I/O you have. So those are the 3 main components for pricing in Aurora, right? And if Jared mentioned for serverless, obviously there is no instances, and that's where ACUs come in, and you get charged for ACUs at that point. So, in furthermore, we also have cost for backups, right? We have cost for the storage consumed and the data transfers. In addition to that, most for any additional features with the customers use, like global databases or backtracks, snapshotting, and things like that, Aurora parallel querying for MySQL databases. Those are all separate charges going for that. So let's look at in individual aspect what this cluster optimization means we're talking about, right? How do we optimize these instances within each Aurora cluster? Now we have, we're talking about 2 different sections here, right? Aurora provisioned cluster and serverless cluster. We always start with, we always get charged for database per hour cost, right? And metered in seconds and with a minimum of 10 minutes. So if you turn up your instance, you're getting charged for 10 minutes. And anything more than 10 minutes, you get a metered cost. And generally the instance, the cost is actually determined per hour. For example, in some of our US regions, the provisioned cost for smallest instance is less than 5 seconds per hour. Right, and that can change, right, over a period of time, and that's where the database instance cost comes in. Now, how do I think about optimizing our solution, right? What do you mean by instance optimization, right? Scaling it. So a lot of times, when I was a database engineer back in my heydays, I used to manage a lot of databases and build a lot of applications, and always provision for the peak usage, right? And we always done that, like, our traditionally, like, we'll be running like at like 8 or 9% GPU, and one of those days, like a prime day coming up next week, next month rather, we have like a sudden spike in our usage, and that's what we are provisioning for. So the remaining like 90% of the days, I'm paying for the extra capacity without actually using it. Now, with the right sizing, what we are saying is, like, we look at it with different options which we have, right? Like, in terms of the CPUs, the scaling methodologies for readers, especially, right? We can always say that, what we can, let's not provision 100%. Let's say we can provision at 50%. That way, like, I can cut my cost in half pretty much, at least for the instance type. And that way, like, you can, if I need more, I can just provision for that, those 10% of the time, and I can start doing some cost savings from that point of view. Now, you can also use reserved instances, and that is probably the most common way of using our instance class. If you know what your optimal workload is, then you probably can use reserved instance, and must use reserved instance for greater cost savings. In fact, we offer like a reserved instance for 1 year reserved instance and 3 year reserved instance with different price bracket involved in that. So we want to evaluate that and want to use some of those things. As like, if your business is just between 9 to 5 and or during a business days for traditional trading systems, right? You don't have to keep it on all the time, right? You can always turn it off like at 7 p.m. and turn it on 7 a.m. next day morning, right? And this works great with development servers or a QA servers, because after hours generally none of these things are used. So you want to think about that as optimization from that point of view. And database consolidation, right? Over a period of time, like, we build so many databases, so many disparate databases having their own instances, their own storage, their own capacity built into it. Now, we can always take this opportunity to consolidate some of those things. So we talked about, we had 128 terabytes of disk space available in Aurora. Make use of that, right? You can bring it all in one place, do the economy of scale, having this one machine rendering all your transactions and read requests, right? Makes it much more efficient to either A, to manage, and B, to make sure the cost is also under budget, right? Under limit. And the last thing is it's pretty curious, right? Like, we talk about tuning and how does it reduce cost, right? In Aurora, if you look, in the next slide I have it in that, is we get charged per IO, right? We get charged per IO. So every time you write or read from the disk, from the storage layer, you get charged. So the less number of writes you do or reads you do, the lower the charges you make for the IO. So tuning your workload to reduce your query is much desired and also recommended. And to be honest, like, when I started back in the 90s, late 90s, I'm not that old, but back in 90s, I was taught to, like, make a query very efficient, design your database very efficient, and because of the price of the disk and the computer at that time, over a period of time in the last few years, since, like, the disk and the storage and the computers becomes cheaper, we have found that, like, we have a lot more database inefficiencies have been creeped in, and now this is the time to revisit some of those things and reduce that. Right, that's a provisioned cluster and provisioned instances as well. Right now, if we look at this DB cluster on the serverless side, it's a kind of it's a complement to what we talked about in instances. So it automatically scales. That means you don't have to provision your instance for your peak capacity. Right now,
Ben, not to jump in there, but it looks like there might have been a little bit of delay. Okay. There was a black screen that was over the serverless DB clusters, so I'm actually sharing my screen right now. So when you want to advance, just let me know, and I'll go to the next slide for you.
No worries, thank you.
Yeah, you're welcome.
Okay. So serverless DB cluster, right? It's it scales automatically, right? And that means you don't have to provision for your peak scale. workload. And that's the things we talked about. Optimization on the server provision side is already, some of the optimization is already done on the serverless side. You can pause your compute capacity. We told that you can turn off your stop your machine. Here you can also actually pause your instances. That way, you can you don't incur charges for off-hour non-usage. Right, and setting up realistic min and max. Now, one of the things which Jared suggested and touched upon, and I think I want to make a little bit of a point there is, min and max is a cost associated with it, right? So min is like the minimum capacity we want to have. So if we have 4 as minimum capacity, and you have 64 as maximum capacity, those are all the costs associated with it. So you always get charged for ACUs. Typically, in ACU is a little bit more than 10 cents per hour, and in the US region, and that can increase as you are scaling up, right?
Yeah,
and again,
yeah.
That adds up, right? So identifying your right min and max is very important. Both in terms of performance, that's a fine balance, right? You don't want to put keep your min so low that it takes the scaling takes a while to hit the max. At the same time, you don't want to keep it so high that you're paying a lot of money for it without being actually using it. So that is a balancing act you have to do, and that way you can help understand your workload and help your optimize your cost. Right, and we talk about cost optimization and not cost reduction, and the reason for that is you pay for what you use, right? And the way we are trying to help you is we try to use the most efficient way so that you can reduce optimize your cost. And in terms of serverless, the thing Dustin touched upon, limit long running transactions. Right, it's that is something serialized transactions. That's of course right does a lot of IOs as well. So that is another aspect you want to control. Right. So moving on to the next slide, we talk about storage optimization. Right now we talked about the instances. Now we talk about the storage, and it's build gigabytes per month increments. Right, we also prorate, right? If you start using from the middle of the month, and if you add a gigabyte at the end of the month, so we prorate those data. Okay. Now, one thing good about
you remove. So if you reduce storage,
that was
okay.
That was my next thing, right? In Aurora, you can reduce storage. You just stole my thunder there. That's why. But
I'm not stealing. I'm stealing your thunder. I'm sorry.
Now, in Aurora, you can reduce the storage as in traditional databases, right? When you add the storage to it, it's very difficult to reduce it, right? And now there are strategies within Aurora where you can reduce the storage. For example, you have a partition, you can drop a large partition, and whatever the partition size was gets sent back to the pool, and that you don't get charged for that piece. Right?
Got it. Okay.
Yeah. So that way, yeah.
And we also have actually a really interesting question in the chat, and I'll go ahead and throw it up here real quick because it does have to do with cost, and they're talking about compute costs. But I'm also curious to hear your answer. So we'll say compute and storage cost. Will there be a difference between each region?
Yeah, absolutely. And the reasons are manifold, right? Because it's first of all the currency rates in different regions. Right, if you're talking about Europe and US and Asia, right, that is a slight difference in that, and also the energy cost and different operational costs associated with it, right? So they are definitely going to be different. So the currency generally what we are talking about, that's why I'm qualifying my numbers on the US regions, right? Because every region can have a different cost associated with it.
Yeah. So while the customers are planning out their database infrastructure, they should keep that in mind.
Yeah, and one of the great things is we have a price calculator which will tell you what it is, right? And it's very simple, calculator.aws, and that's it. And you go there, choose your region, and you can calculate all the costs associated based on the workload. Right. in that in the storage section as well, right? You drop a older partition, make sure that you don't keep older partition, and there's a reason behind it. Right? Every time you run a transaction, if you have a lot of unwanted data sitting in a table, your database, your optimizer looks at all those data and discards it. Even an act of looking is actually an IO, so you're adding to your cost. So to keep your table size nimble and small, so that again you're reading and writing a smaller amount of data sets, right? So we're talking a lot of IO is coming again and again, and we have a separate section for that, because IO is one of the things which is different in Aurora, and that's what you got to keep in mind. Now, most common use case we have with our databases, not just with Aurora, with most databases, is using our text or blob objects using or S3. Right, S3 is you can put all you put is, if you have a great picture of yours and if you are storing some PDFs, throw it in S3 and put a link in the database table. That way, you are not searching or reading or writing from a blob, and that way, again, the storage cost associated with it also reduce. And we also reduce the updates to the table. Right, updates using caching technology for transient data, and what that means is, like, a lot of times we have the final state of the data is determined after a few operations, right? And you have multiple updates going in the midst. The reason is update is a unique feature in databases, which has generally is a delete followed by an insert. And every time you insert something, it is inserted at the end of the table, not at the place where it deleted. So it's creating empty blocks in the middle of those the data table, and that is storage which you're paying for. So to keep your storage costs low, you want to use something like a caching technique like elastic cache, which is great for transient data, and store only the final copy of the data in the version in your database. That way, you're also reducing your table size, of course, increasing performance efficiency, IOs, and all those things, but also have the storage cost. Indexes, we all know about it, right? Like, we've been creating indexes for forever now, and in our old days, in the traditional databases, we create the index, we don't use it, doesn't matter, it's just lying there. But it actually has performance impacts and storage, of course. And you can have a lifecycle management with the S3 as well. So you want to frequently dump your database into S3 and probably push the S3 database into Glacier and data into Glacier for compliance and other purposes. Right. Moving on to the next one on the IO cost. So we have like, again, we have writes and reads, and these two components combine your IO, right? People. They are the quantum of that particular reads and writes are different for how we get billed. For example, right, for every 1 million writes of 4 kilobits each, right, the request per month, that's how the writes get charged, right? And the reads are 1 million read operations for 16 kilobit units, right, are consumed per month. That's how the costs have been developed. Right. So when you do an Aurora cluster IO operation, the data pages are read and the pages are not kept in caches. So we talk about buffer caching techniques, right? Now, the second thing we have to think about is on the instance side itself, right? Like, you can go for smaller instance. At the same time, we want to right size it. We call it right sizing it, because we want to have cache big enough that the data is sitting in there and the query you are reading is hitting that cache, right? Because if we don't hit that cache, it's going to hit the storage and going to do an IO on that storage.
It's going to cost more money.
It costs more money, exactly.
Yeah.
So, it's a balance, right? Like, you pay for have bigger instances with bigger cache. At the same, then you can reduce your IO cost, or you can go for a smaller instance with lower cache, a smaller cache, and increase your IO cost. So now that's your workload dependent how that behaves, right? And that's where your right sizing, your optimization piece comes into picture.
Got it. And we talked about compute cost, storage cost, IO cost, and so forth. Yeah. Is there a free tier for those who are just getting started?
There is a free tier, mostly on the instance size. I think it's T2 small, I believe, but not sure it's for Aurora or RDS. But I think there are some probably you have the $500 credits coming up today, right, Adam? So probably you can use that as a startup for Aurora. But there are some costs associated with it when you start with Aurora, right? So then so there are certain features of Aurora bypasses the cache, and that one is the Aurora parallel queries, right, on MySQL database. These if you're turning it on, you make sure that you have a good reason for doing it. And the reason for that is this one does not hit the cache at all. It directly goes to the storage. The parallel query actually is distributed querying happening at the storage level, and then you compile all the data and bring it up and produce to the engine and to the requester. So that way you're getting good performance, but you pay. That's always you pay for what you get, right? Like you're paying for good performance, you pay extra money, extra cost associated with that. Right, and in terms of rights, we already talked about some of those the updates. We talk about redo log events, right, based on the DML operations, logging, right. You have a lot of replication technologies like MSQL by binary logging or Postgres replication, or like PG logical. Those are all is an write and a read into your database. So these are additional costs associated with it. You might have a good reason to have it, and there's nothing stopping you from doing that. But just keep in mind that if you use some of these techniques, you might want to think about the cost aspect of it as well. Right. In the next slide, we're talking about how do I optimize Aurora IO cost. We already spoke a lot about this. I touched about IO many times. Let me quickly run through this and see if we can, if anything new comes up, right? So there are we call it boxcar concurrent writes, right? So for transaction log, right, less than 4. So if you have 4 KB less than, if you remember it, right, like each write is 4 KB. Build at 4 KB and at the minimum of 4 KB, 4 kilobits, right? So in that case, if it has a boxcar concurrent write process where it kind of combines all your transaction and tries to write it in one shot, right? And that way you don't incur additional costs for multiple writes. Again, we talked about low value secondary index. We talked about that. There are a lot of techniques out there to optimize your table. Like for in Postgres world, you have vacuuming. In MySQL world, you have optimizing, right? Optimized table, right? So those things are great. Basically, it gives you back the data which you're not, the space which you're not using, make the table more performant. But what it also does is rearranges a lot of the data sitting in the table, right? And rearranging those data sets again has got an IO cost component to it, right? While it is a critical aspect of any performance tuning mechanism within an organization, doing it on a table which does not need to do it, right? Now that might be an wastage of resources first, and then also the cost associated with it, right? So now you got to pick and choose what tables you want to optimize, right? And we talked about bin log logical replication because it's hitting the transaction log. So suggestion is used like one-to-many, like an Q or an Kinesis or Amazon Kinesis data streams, managed Kafka services, right? Because these are one-to-many. So replication like PG logical are generally one-to-one, right? You have one writer, one reader, but with Kafka I can go to multiple different subscribers, right? I can have a reader, I can have a S3, I can have something else or Lambda going on that, and that way, like I can reduce the load on the primary data cluster.
Awesome. We talked about compute and storage, and now we are wrapping up our Amazon Aurora IO costs. And there's a question in the chat around vacuum pricing. Are you able to maybe touch on that?
So, yeah, do vacuum, yes, because vacuum does just rearrange the data tables, right? The tuples are rearranged during your doing. There are different ways of doing it. If you're doing a vacuum all, you are basically doing creating pretty much a new table, right? For example, PG repack copies the entire table into a new table and renames it. That way, the table is much more compact and much more performant. But the downside to that is it is reading and writing the entire table out. So there is a cost associated with it.
Okay, thank you.
Yeah, so That's what. Again, we want to run through some of the read optimizations, right? We have analytic query. Analytic query, generally ETL queries have a larger data set coming out. So most of the time it will not hit the cache, right? It'll most likely it'll hit hit a database storage level, and that way you're going to get it. So best way to do move some of these OLAP kind of an analytic queries into an a workload Redshift and other tools based on that. Tuning your queries, avoid table scan. This is like tuning 101, right? Avoid table scans. They've been kind of drilled into us forever now. And DB instance, that's something I already touched upon. Scaling your DB instance to have more memory for better cache performance, right? And we also have tune auto vacuum process in Aurora Postgres with high DML operations, right? Because
An auto vacuum that's managing the vacuum and the analyze process, right?
Yes. Yeah.
Okay.
So analyze basically creates statistics around that, and a vacuum gives you the free space back to you for the database to use. Right. Now with that kind of optimize your table. It's a very important aspect of performance tuning. At the same time, you got to be mindful of the cost associated with it. Right. We want to reduce indexes because indexes are write, and it creates bloat, and also we unnecessarily we create read operations as well if the index is bigger than what is required. Again, we talked about how we don't want to do a vacuum on the tables, or vacuum or optimize tables on tables which are low value and not has a high write transactions going in. A lot of times you require vacuuming because you are writing a lot of times to the table, doing updates and deletes and inserts. So if you look at it, that's a common theme here, right? Don't do updates, don't do writes too much, right? Writes as minimum as possible, so that you can avoid doing your transaction vacuuming or optimizing table, and that way, you can reduce your cost. So it is all it's like a daisy chain going down. So everything what you do upstairs, it comes down and hits you on the cost on the lower side.
It reminds me of setting up dominoes, and then you eventually just hit the first one, and the whole thing just falls over.
Yeah. That's how it is. So it's always starts with the designing aspect from the start, right? And you always want to think about how cost should be cost is always a high priority, but now with Aurora it becomes a little bit more granular and it's more specific, right? Now we know, hey, if I do this, I'm going to get charged, right? And so these are the ways for me to options to reduce it. So that way I can help it. All right, moving on to the next section here. Next slide is backup and storage cost. Now, with Aurora, like we always talk about storage and cost associated with it. Dustin mentioned we make 6 copies of it. No, you're not getting charged 6 times. You're getting charged only once for storage. That's a common question I get asked, right? You get charged 6 times. Now, the backup is also similar to storage, right? Database storage. It is consumed from gigabyte per month. Also, you get 1 gigabyte. You get the size of your database, 1 backup as size of a database free every month. Right. For example, your size of database is 10 GB and your backup is like 11 GB. So you get the first 10 GB free, and you get charged for the 11 GB. Right. And that's how it works. So that's what 100% of the cluster storage size is for each cluster. So that's what I mentioned. Not for 1 day automation backup retention, same thing, because the last 1 day is your size of your cluster. The snapshot taken within a backup retention does not count to your backup storage, right? That's simple as that, because snapshots are outside of your databases and it doesn't come under the storage level, right? And automated backups reflect data changes during the retention period, and snapshot are built for the full snapshot size. So one of the things I'll touch upon it when we hit the S3 side of it as well, what it means, because you have an option of pick and choosing what tables I am restoring, and that way you're getting that, but you're always getting billed for the full snapshot. Right. So this is very important, right? Backup and retention policies is very important. It's probably one of the most critical functions within any organization, and managing SLAs with a business is critical for your business growth, right? And keeping the lights on. So you want to have a right tool. So you want to, if you create too many backups, you get charged too many times. Now it also Dustin did touch upon backtrack and point in time recovery, and automatic backups by default. Maximum big retention is for 35 days, right? And that means if I do a point in time recovery, I can go back 35 days if I have that enabled. Now, that sounds great, right? But are you planning for the exception, or are you planning for the generality? So how many times somebody drops a table, for example, right? And if you drop a table, if you don't realize it in 30 days, probably you don't need that table, right? And but if you want it, so typically we go back 5 to 7 days to get the data back. So I'm not saying that you got to be 5 to 7 days, but based on a use case, you want to really evaluate how long you want to retain your backups, right? There are always manual backups as part of Aurora, which can be retained forever, right? So you want to think about that, and that way you can also have better retention policies like S3 and Glacier as well. Right?
Is it possible to have those backups longer than 35 days? Let's say there's a compliance requirement where we have to hold the data for 2 years.
Yes. Yeah, absolutely. That's why we call manual snapshots. So there are two backups going on, right? We talked about, Dustin talked about it. One is the automated backups or automated snapshots, which can go maximum of 35 days. And then it's
35 days, right?
Maximum 35 days back.
Yeah.
But if you go to manual snapshots, which I go to the console and say, hey, take a backup. But do a snapshot right now. That snapshot basically can be retained forever. Right?
Until we delete it or have some kind of process. Okay.
So that is up to you to manage the life cycle of that backup, because that's manual. And that is a good option as well if you're looking for a longer retention period. Data transfer optimization, right? So there are transfer costs associated with it. Now, okay, any data transferred out of internet, right, pulled out of database, out of BPC is charged. Right now, the compute services within the AZ is free. Right, not all of services have the same structure. Some services are network data is charged for network traffic across the AZs as well. With Aurora 6 copies underneath, you're not charged for the AZs, the storage level rights.
Yeah, you mentioned that there's 6 copies. You're not charged 6 times, only once.
Yes, same thing with so that is for writes and reads, right, for iOS. Even for network traffic, the data is transferred from one instance to one AZ to the other to write, right? So that is not charged as well, right? So all the instance, but what is charged is if you're running a query, and I'm running a query from internet, and I'm trying to pull the data out of that of the database, that is what I'm charged for. When you have global databases, so that's the next slide, I believe. In the global databases, when you do that, so we get charged for iOS as well, because it is an inter-regional transfer. It is not an easy transfer, right? So with Aurora global databases, the cost, of course, we talked about the compute, the instance type of the compute. We have the storage, because you're actually copying it from your primary location to your other location. So there is a separate storage gets allocated for that cluster in the other region, and you do get charged for the storage once. You get charged for iOS because you're still writing it there. If you're making backups from that secondary region, you get charged for the backup as well, with the condition that the first 100% is free. And apart from that, what you get charged is IO. It's a network traffic. So because the data is going from your primary region to your secondary region, as with any AWS service, we are moving data from one region to the other, you get charged for the network traffic. Right now, if you're going back to our old parlance of writing and limiting your updates and writes, right? So limit your number of writes, limit your number of updates, right, or deletes. So you have a smaller table, so less storage. Now you can also have a smaller data set going over the network. So you have less network charge as well. So the data is transferred when the new data is returned or written on the database, and that data is transferred, and that's when you get charged. So if you write less, you get low I/O, you are low storage, and then you also low network fee associated with it. So what I mean by write less is not like skip writing, just that be optimized how you write it, and have designed the application in such a way that only the final copy of the data is written. And that's not always possible, but that's a goal at least, right? Next is backtrack optimization. Again, the
Actually,
backtrack.
if you don't
Yeah.
mind, before we move on, you talked about backups and global database and backups and so forth. And there's a comment in the chat, and they're asking about how to move backups between different storage classes to help reduce cost.
Okay. So backups can be using snapshots, right? You can export the data into S3. That was my next slide anyway. So if when you move to S3, right? Once and you can put it in the slide after this one, brother. But so we can move to S3, right? And you can move the data from S3 into your Glacier as your permanent storage, right? So what happens is when you're taking a snapshot and you're exporting your data from onto S3, what you're doing there is basically taking the data sets and converting in your Parquet file and putting it in S3. Now you can use Athena or some other tools on top of it to run and query on top of on those data sets. Now, in this case, now we are already in the slide, so we'll talk about the snapshot size, right? So what is the right aspect of it? How much do you get charged for it, right? So if you have a snapshot of 10 GB and you basically transfer the 10 GB out there, of course you're going to get transferred. The cost will be of 10 GB, right? But if you just want to replicate one table, right? Because this S3 exports lets you choose specific parts of your data to transfer data, right? So for example, I can do a particular simple database or a particular schema or a particular table, but the cost associated with it is not per what is written, but actually for the entire snapshot. So you gotta be you might think that I'm doing only one table, even though it's a small table, you're actually getting charged for the entire snapshot size. So the idea here is to make sure once you export it, you already export once you already exported it, don't re-export it, reuse whatever is there, so that you reduce your cost associated with that, the snapshot size and the cost associated with those things.
Awesome. Thank you so much for answering that and for entertaining the question. I know we skipped one slide and we talked about, what was it? Aurora
Backtrack.
Backtrack? Yeah.
Yeah.
See if we can get
Let's
that
go back
up.
to the backtrack. Yep. Yeah. So what is backtrack, right? So we talked about the retention for 35 days, right? So backtrack is basically digging your database and going back to a state where to a state sometime in the past, right? I can, if I have if I, as I said, if I dropped a table or did something which is not supposed to be done, and I want to get to the state where I want to do it, so it gets pushed to that date and time. Now that is what backtrack is, right? Now the backtrack retention is based on the number of days of backup I have. So I told you, we have 35 days of maximum backup for automated backups. So if we keep 35 days of automated backups, that's going to be a lot of costs. It's going to be a big one, and it could be cost associated with it, right? So that the backtrack optimization is you coming up with the right number of days to retain, so that you can accomplish all your the task and your backtrack recognition or your SLAs, all your DR policies, all of them are in sync with that, right? And the cost is calculated based on the backtrack duration in number of hours and number of change record per hour, right? Because it has to roll back some of those transactions going back. So there's a set of backup window for the SLAs and this thing. And this is not an absolute necessary. This is, again, it's an add-on. Like global database is an add-on, right? It's an enable to enabled. It's enabled feature. You can want to enable it. It's good if you think that there is an option for it, but you don't have to do it. But there are other options you can live with backups and daily backups and manual backups. So then this is not needed. But a lot of our customers use it purely for contingency purposes. So. Right. So I think that's about the cost optimization piece of it. So can we put to the next section, which is monitoring metrics? So now I talked to you about what are the different costs associated with it. Hey Venkat, you talked about all the costs, how do I get billed, and what all things I do. But how do I know what I'm getting billed? What should I do to make sure that my metrics, my consumption is the right size, my instance is right sized, my storage is optimized, my IOs are precise. Right, and that's why we look at the monitoring metrics, basically to use those information to make those decisions. Right. Going on to the next slide, where we talk about the concept of some of the metrics principles what we have on the on our CloudWatch monitors. Right. So these are some of the metrics. For example, we have the 5 boxes laid out here. If you realize it, there are five different categories I kind of covered in the previous section. Now we have compute right sizing, you have Backtrack, you have backups, you have global databases, and your storage and IO. Now the metrics listed in there kind of outlines what is going to be your CPU utilization, what is going to be your free memory, and what is going to be your buffer cache hit ratio. We're always talking about caching. We talked about, hey, if you had to hit more cache, don't hit the database, don't hit the storage, hit cache. That is your metrics for it. You want to see if it has to be high enough. It should be, ideally, it should be 100 to get the maximum to make sure, but not always it's 100, but it has to be somewhere up there, so that you're making sure that your data, your queries are hitting your
optimizing the cache queries versus the actual read queries against the database.
Absolutely, yep.
Yeah, and you can monitor all of that directly through. Okay.
CloudWatch, you can monitor right on CloudWatch. These are all CloudWatch metrics. If you go to the console, you will see those metrics right on the cluster.
I see the CloudWatch icon here. It's on the bottom right-hand corner. That's CloudWatch.
That was exactly for that reason.
Yeah,
right?
Cool.
So, so the other things you're talking about Backtrack, we have backups. Some of the things you just talked about, there are some self-explanatory metrics out there which talks about that, right? How do you want to do that? Right, and we also have storage and IOs, what is the byte used, what is the read IOPS, what is the write IOPS. So it'll get an idea of how you are doing in terms of reads and writes, right? And one other trick I'll tell you is, when you see a buffer cache hit ratio, the graph going down, you will see the read IOPS graph going up. That tells you that
typically there's direct correlation between that way. Okay.
So that's exactly what. So basically, you want to keep off those anomalies. Great thing about this monitoring service is I can create alarms on it, right? Hey, if my buffer cache hits goes below 60, raise the alarm. So I'll get
trigger and get notified.
Yeah. For example, if my storage is breaching a particular threshold, I can raise an alarm. Same thing with compute. My CPU is around 70%, raise alarm. So these are all great things for you to keep on top of some of those things, right? And making sure that you are keeping on top of this cost optimization.
Yeah, and with compute, because you have an alarm through CloudWatch alarms, you can get an alert through simple notification service, or you could do both. You could trigger a Lambda function to also make an adjustment too.
Absolutely, and and I think Jared mentioned that in his serverless. Right, how I think it was you mentioned, Aaron, talked about writing a Lambda as well. That this is exactly how we do it, right? We can based on some of the things. So we have auto scaling features which will do that, but we can also use this feature to trigger some of those things, right? Moving on, next one is the next section is tracking. How we want to track your costs. So now we talked about how we are measuring it. So now how we track it, right? So we do it based on tagging, right? So if we go to the next slide, Aaron, there is an consolidated monthly bill, right? And here you can see you have multiple Aurora services going on here, and you're talking about storage, you're talking about your database services. We don't know what's what, right? How do you break it down? So how do you tell me that this particular instance is being charged this much, right? The way you want to do it is next slide. You want to create an tag, right? The tag, you can say its environment is test or whatever. Like the cluster name is XYZ. And the next, if you and you can tag your database, you can tag your instances, you can tag your snapshots, and all for cost tracking. And in the next slide, you can see you can go to your monthly billing console and you can activate your cost, activate the cost tracking based on that particular tag you have. And then the next slide, if you can see, you can monitor it. If you can see your cost based on the tags. If you look at on the top left side, you have a tag environment is being circled, and you're basically the graph which is seen here is for the cost associated with that particular tag. It's a great way to track your cost. Now, what a lot of our customers will also tell me, like, you know what, I want to keep my development costs low. The best way to do it is create tags, right? A lot of people do
with tags. Is it case sensitive, or do I have to be aware of that?
It's a good question. I will always create uppercase, but I got to check it out on that one. But make sure that like it can be consistent with the case. I generally use uppercase to go with it.
Yeah, cool, awesome.
Right. I think that's about how you want to track cost, how you want to keep on top of it. It is very, very important in terms of how you want to budget as well. So this is a great way of doing it. Now, the next the final section of this thing is designed for sustainability, right? And I'm very passionate about this thing because we recently introduced this pillar, right? And this pillar is also part of well-architected review, and it's about, so cost optimization is not about dollars and cents. It's also about reducing your carbon footprint, that thereby you reduce your impact on how we have on the future generation. Right now, carbon is of course the fourth most abundant element, and whenever it combined with oxygen, it creates carbon dioxide. For a chemistry lesson for somebody who don't know. But it's many industrial activities like driving, including driving a car, and with burning fossil fuels generates carbon dioxide, and it causes climate change. And as part of Amazon's effort to increase sustainability, right, and reduce carbon emission, we co-founded the Climate Pledge in 2019. And in this section, we're going to see how AWS services are designed in such a way that it reduces our carbon footprint, and also to show you some tools how we track it. Yeah? So moving on to the next slide. So this slide you already seeing here is there is an independent research 451 research has been published back in 2018, 2019, I believe. And what it says is like, running applications on AWS cloud can help lower your carbon footprint by 88%, right? And that's when compared to an enterprise data centers that was surveyed. And of course, the report has been detailed out, and the link is mentioned in the bottom of the screen. If anybody wants to look it up. But if you look at the breakdown of it, right, like 61% of them is by carbon reduction, attributing the efficient servers and higher utilization. We always talk about economy of scale in AWS, right? It also applies to sustainability. Right? Instead of me running 10 servers doing 10 independent jobs, if I can run the same jobs in one server, right? It reduces it reduces the carbon footprint by using less resources. In addition to that, now we also have efficient data centers, right? And we use a lot of times you hear we talk about generating your own power, like using renewable energies, right? So some of those aspect as well. And also with the last part is attributed to reduce electric consumption because of renewable energies. Now, each region has got its different quirks around the availability of the resources on the energy value quotient on particular region, right? The numbers might differ, the sustainability numbers might differ. And I think it's also, somebody asked me earlier, right? The cost is different. And the same applies to sustainability as well, right? This depends on the regions of it. But if you look at this whole aspect of it, right? So you can basically split it down into our architecture principles, right? For example, right, if you look at the reliability pillar, right, and you're taking a closer look at it, so taking data closer to the customer, right, reduces long distance round trips, and of course saving resource. Now we talk about Aurora Global Database as a dedicated AWS network, right? So it uses the underlying AWS network, and it is, as we know, AWS dedicated AWS network backbone infrastructure is highly redundant, right? It gives you much more sustainability. At the same time, it is also built in such a way that, like, you get more sustainable, right? Based on our pledge on the climate pledge we have. So this enhancements in the resources and infrastructure, it's more efficient to move data across regions than traditionally, like cross region replication across region installations, right? Now we can also, of course, now we again come back to the database query, right? The less the number of optimize the data, you have less storage, less IO. We also consume less resources, thereby having less carbon emissions based on that, right? You want to implement a good data classification policy, right? Because there are a lot of times the data is just spread around, a lot of redundancy of data, and we don't think about it. How does the data redundancy help with sustainability, right? And think about it, right? Every time you move your data somewhere, you're writing the data somewhere. So it's occupying storage, you're doing IO on top of it, and every IO, apart from having a cost associated with it, it also has a carbon impact on it. So reducing your IO becomes your general redundancy helps. If we can keep it consolidated, it gives you better posture for sustainability. As lifecycle policies, again, delete unnecessary data. If you don't throw away things, my mom tell me throw away things you don't need, right? And and that's true with this as well, right?
If you don't need it, don't keep it. Throw it away.
Yeah, throw it away, exactly. Yes. And if you really need it, put it in Glacier or something and keep it in one place, right? Don't keep it multiple copies of those. And increase utilization, right? You leverage your stop and starting instances, right? Again, it's nothing different. I'm talking here in sustainability because the same thing with cost optimization. Starting and stopping resources, you reduce your carbon emissions or heat generated by the machine. So those are the things you can reduce them. Using Graviton instances. Graviton is an ARM-based instance with AWS, and it's built with sustainability in mind. It uses less resources than then. And Aurora Serverless. Aurora Serverless is also a sustainability aspect because you use only what you want. You are not provisioning for your peak, but using only what you want. So that way, you want to make sure that you have your you use what you want. You're choosing the right ACU so that you can have the right posture around sustainability. Right? And in any questions on that, please feel free to ask me on that, because I'm passionate about it, and this is something which we are striving hard to educate ourselves and everybody else as well.
Yeah, sustainability is such an important concept, not just for what we're trying to do, but also just the entire planet and our future generations too. So if we can do our part by stopping and starting instances and maybe using more managed services or serverless services, that all helps, because then it takes away the overhead that we have as consumers, because we all have a piece in that. And you mentioned the carbon footprint tool a couple of times. Are you going to talk more about that?
That is the next slide there, right there. You want to move on to the next slide there. Carbon footprint tool. So this tool is available for you. If your consumer wants to know, if you want to know more about the infrastructure, you can track, measure, review, and forecast it, right? Based on the general emissions per footprint. So you can take a look at that. So in a case in point is each in different energy grids in different parts of the world, there are different uses of sources of power. For example, like some use coal, some use heat, some use fuel, some use nuclear, right? Most of them are using like the carbon. Most of them are using coal as probably the primary driver as well. There are some other low carbon footprint energy generation is like hydro power as well, right? Now with energy, the Amazon's energy renewable projects play a role because energy products produced by these projects are accounted against the emissions from each region on the same grid, right? And if you can look at that, carbon emissions on the right is what US summary is. Now it's also measured in metric tons, so that's what the number around is. So this will give you that whole what are you using, right? It also includes the path towards 100% renewable energy and getting you some of those things there. Yep, metric tons. On the right side, you will see the carbon emission summary there. So it gives you an overall picture about how much you're using. And this, by the way, in my entire presentation today, this one thing has no cost associated with it. So it's free, of course. Anybody can.
Wait, no cost?
This report has got no cost to it. So
you triggered my wake word. It's like free.
It's free. Yeah, it is free. That's right. So make use of this, and as a responsible citizen of this world, we can do our bit to contribute towards that. Right.
And it's free. So, it's free.
It's free. Yeah, it's free. Right. You don't even need to use your $500 credit for that.
Oh, nice. And if you want to know more about how to get the $500 credit, let's do this. Go to new with Amazon Aurora.splashthat.com. There's a banner kind of scrolling across the bottom of the page here. And make sure to register by July 1st. And you'll be eligible to receive a $500 AWS credit. So do that.
Yes.
All right, Venkat.
Yeah, with that,
anything else you want to add?
No. That's it. Go to explore your workloads on Aurora and see how much money and performance you can save. So,
awesome.
Perfect. All right. Any questions coming up on the chat here? See,
I did have one. Let's see here. So one person said moving backups to Glacier will be more cost effective. We answered that one. And let's see. If you have any questions, go ahead and throw them in the chat. Type them. We will do our best to answer them. You know what? You have a fan. You have a fan here.
Thanks, Dinesh. So I'm on Instagram as well, so I can become an influencer. Thank you.
Great.
All right. Cool. Thank you so much for being here. Appreciate it. For the rest of you who are still tuning in and still hanging out with us, stay tuned. We're going to be right back here pretty soon, and we will have Bachar, who is going to lead us through the very final session of our What's New with Amazon Aurora Day on how to leverage partners and partner engagement strategies. So, Bachar, you're coming up here right next. And Venkat, thank you so much for being up here with us. Brian, thanks for being a great host. And I'll see everyone here soon.
So we said thanks, right. A and B. That's what we say. Thanks, A and B.
Hey, there you go. I like that. A and B. It's an A and B show. we have another host who's his single name is AM, but now we have A and B. All right, Venkat.
See you then. Thank you, guys.
Everyone, take care. Stay tuned.